Okay, now we can discuss to the stereochemistry. So first thing is that what is isomerism? So isomerism means compound having same molecular formula but different structure or arrangement is known as isomerism. What does it mean? It means suppose you have CH3 CH2 OH and you have another molecule CH3O CH3. So if you are going to find the molecular formula of these two compounds, suppose I am talking about this one. So it will be C2, hydrogen is 6 and oxygen is 1. So it will be C2H6O and this one also C2H6O. So now you can see they both have the same molecular formula and so they are isomer of each other. This one is known as alcohol and this one is known as ether. I just started, we are talking about isomerism. So isomerism means compound having same molecular formula, but different structure. As you can see, alcohol's molecular formula in this compound is C2H6O, ether having C2H6O. So they both have same molecular formula. So we can say they are isomer of each other. One is alcohol and one is ether. Yes, they have different structure and same molecular formula. So they are isomer of each other. Any doubt about this one? Please tell me. My request to everyone, please tell me any doubt. Perfect. Okay. Now it is categorized in two categories. Isomers has been categorized in two categories. One is constitutional and another one is stereo. So constitutional means same molecular formula with different structures. Different structure means it may be difference in the functional group. It may be difference in the position of double bond, difference in position of multiple bond, double bond, triple bond, or it may be the difference in the chain or branch. So they are known as constitutional isomer. Example is very clear. Suppose you have this one and we have another compound, this one. If you look at A and B, they have same molecular formula, that is C3H6O. C3H6O here as well as here. And if you look at the difference, this is ketone, while this is an alcohol, or enol, you can say enol and alcohol both are same thing. So they have different functional groups. So we can say they are the constitutional isomer. Any doubt about constitutional isomer? Please tell me. My request to everyone, please tell me any doubt. Yeah, perfect. So as you can see, in case of constitutional, they have difference in the functional group, difference in the double bond position as well. I am going to give you an example of double bond. Suppose you have this one. You can see here. This is double bond is present between 1 and 2 position, and here it is present between 2 and 3 position. So the difference in the position of double bond, so they are also known as constitutional isomer. Any doubt? Please tell me. Okay. Now we are going to discuss stereo. So what is stereo? Suppose we have two compound. A and B. I am talking about stereoisomerism. Suppose we have two compound A and B. If they have same molecular formula, you can say they have definitely same molecular formula because same groups in A and same groups present in the B. So we can say same molecular formula. And next thing is same connectivity as well. Same connectivity. Same connectivity means you can see here nitrogen is bonded to this carbon, OH is bonded to the carbon, hydrogen is bonded to carbon, bromine is bonded to carbon. And here the same thing, nitrogen, OH, Br and hydrogen means groups are same. So when the groups are same, we can say this is same connectivity. Now the difference is exactly the location of the bonds. Location of the bonds means here an H2 is present on the vertical axis. This is vertical. And here an H2 is present in the horizontal. So whenever they have different arrangement, they are known as stereoisomers. So the thing is that compound having same molecular formula, same connectivity, but different arrangements are known as stereoisomers. So they are, stereoisomer of each other. Any doubt? Please tell me. Please tell me any doubt about this one. Yeah, what's the difference between stereo and constitutional? Listen, in constitutional, the same groups will not be there. It can be anything. Suppose here you can take like OH or CHO and they have same molecular formula, but groups are different, then you can say that will be constitutional. But in case of stereo, groups must be the same. You can see here you have OH, here you have OH, NH2, NH2, bromine, bromine, and hydrogen, and hydrogen. So whenever the groups are same, that is known as stereo. Now we can move to the next thing. And in your GAM set, stereo is more important than constitutional isomer. So I will discuss stereo. And now I'm going to talk about chiral center. Chiral center is also known as asymmetric center. Asymmetric center. So what is a chiral center? So we can say any center can be chiral. Any center can be chiral, but it should have 4 different connectivity. This line is very, very important. 4 different connectivity. If they have 4 different connectivity, we can say it will be chiral. 4 different connectivity. Suppose we have carbon, we have A, we have B, we have C, we have D. So now you can see this carbon has 4 different connectivity. So this carbon will behave as chiral center. Any doubt? No, chiral is not only the carbon. Chiral, any atom can be chiral, but in your syllabus, it is generally about carbon. So that's why I'm talking about carbon only. But it can be anything. Suppose you can take nitrogen as well. If you have nitrogen methyl, if you have a hydrogen, and if you have a ethyl branch, and if you have a lone pair. So now you can see this nitrogen also have 4 different connectivity. So this is also chiral. But in your syllabus, generally it is all about carbon. So we can talk about carbon only. But chiral can be any atom. It's not the property of only carbon. Yes, double bond will never be the chiral one. The reason is that I am talking about 4 different connectivity. So carbon connected with 4 different groups only in case of single bond. If you will associate double bond to the carbon like this, suppose A, suppose B, suppose C. Now you can see it has only 3 connectivity, 1, 2, and 3. That is not be the chiral. It makes sense to you? Please tell me. My request to everyone. Please tell me. Very good. Now we can do the example. Suppose we have this one. Sometimes in, you know what? In modern chemistry, generally they will ask everything in terms of name of the compound. Name of the compound means they will say how many chiral center in 2-bromobutane. They will say like this, 2-bromobutane. So now here we have 2 questions. One, what is the structure of 2-bromobutane? And next, how many chiral center? So this is a modern approach of questions. So 2-bromobutane, what the mean of this? Listen, But means 4 carbon. 1, 2, 3, 4. N approaches for single bond only. Single bond. So that's why I have connected everything is single bond. And now I will balance this one. But as you can see, this is 2-bromo. So we will associate bromine at number 2 location. Suppose this is 1, this is 2, this is 3, this is 4. So this is my bromine. Now I will check the valency of each carbon. Now I will check the valency of the carbon. So as you can see, number 1 have 3 hydrogen when you will valence this one, because carbon valency is 4. Number 4 also have 3 hydrogen. Number 3 have 2. Number 2 have just 1. So now tell me how many chiral center on this compound. I'm waiting. Yeah, someone is saying none. 0. My request to everyone, please tell me what should be, how many chiral center? Okay, now I am going to check this. This is very important concept. Listen, let's check one by one. First, I will talk about carbon number 1. And I tell you, carbon number 1, what should be the condition of chirality? Chiral should have 4 different connectivity. If you look at carbon number 1, it has same hydrogen atom, so it will not be the chiral. That is very simple. Similarly, carbon 4 is also not chiral because it has same connectivity. Carbon 3 also not be chiral because it has 2 same hydrogen. Now there is only one possibility at carbon number 2 only. So I will check carbon number 2 like this. So as you can see, carbon number 2, suppose this is carbon number 2. One bond is bromine, one bond is hydrogen, one bond is methyl, and one bond is 2 carbon chain, means ethyl, like this, CH2, CH3. And you can see bromine is different, hydrogen is different, methyl is different, and ethyl is different. So if you talk about carbon number 2, it has 4 different connectivity. This entire group is different. This one is different. Bromine is different. Hydrogen is different. So there is only one chiral center. Any doubt? Tell me, please. This is a very important concept. Believe me, stereochemistry is one of the most important topic in GAMSAT. Okay. This one for you. How many chiral center in this compound? I can mark every carbon as number, so it will be easy for you to tell me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have marked every carbon with number. So tell me how many chiral center is present in this compound. I got one answer. Someone is saying 5. Yeah, 2 votes for 5. Oh, so that is 4. Someone is saying 4. So 5, 2 votes, now 1 vote only. Please tell me, my request to everyone, please answer this question. How many chiral center? Yeah, it is a competition between 4 and 5. Now I am going to check this. Listen. This is carbon number 10 is a carbon which is methyl. So listen, every CH3 group will not be the chiral. The simple thing, because hydrogen is same. So this is not chiral. This is not chiral. This is not chiral. This one is not chiral. And this is also CH3, which is not a chiral. Now we can check number 2. If you will balance number 2, you can add 1 hydrogen because carbon valency is 4. So OH is different, hydrogen is different, this branch is methyl, and this branch is just a CH group. So it is a chiral center which has 4 different connectivity. Similarly, we can check number 3 as well. 1 hydrogen you can add. This branch is different, this branch is different, and above is different. Different means connectivity. You can see, suppose I am talking about carbon number 3. Carbon number 3 has, this is CH3. This is CH3 with OH is there, OH. And this is CH3. And this is a hydrogen. You can see this group is different, this group is different, this is different, and hydrogen is different. So this is 3 is chiral as well. 4 is also chiral if you check. hydrogen, methyl, and this left and right connectivity. Bromine is also the chiral center, this 5 number position, because it has also 4 different connectivity. And thus number 6 is not being chiral. The reason is that it has same group connected, methyl and methyl. So how many chiral center? 1, 2, 3, and 4. 4 chiral center. It makes sense to you guys? Please tell me. Any doubt? You can say carbon number 3 have different connectivity. Left is methyl, one is hydrogen, and top is OH containing branch, and the right side has hydrocarbon chain, which is different in nature. So number 3 is also a chiral center. Now we can discuss in the ring. Chirality in the ring. So if you are going to discuss chirality in the ring, suppose we have 6-member ring, and you know that every carbon will contain 2 hydrogen. 2 hydrogen. Every carbon have when you will balance. It means this compound has no chiral center right now, 0. Because every carbon has 2 same connectivity. And suppose we have this one, and we can put a hydrogen here when you will balance. Now I'm going to check chirality over this circle. Methyl is different, no doubt. Hydrogen is different, no doubt. Now the left branch is CH2 when you will balance, CH2. Right is also CH2, which is same in nature. So the rule is here, when you will get same thing in a very first position, then there is no need to stop here. You have to move forward. Again, you can see this is CH2. And again here CH2, the right also CH2. And in the terminal position, you can see this is CH2 as well, which is common for both. It means for this X position, it has only 2 different connectivity, while the left position and the right position are same in nature. It means it has no 4 different connectivity. So we can say again a 0 chiral center. Any doubt? Chirality in the ring. Please tell me any doubt. Yeah, this is not, it has no chiral center, so it will not be the chiral one. Now we can move to this example. Suppose we have this one. Suppose this is position X, this is position Y. I am talking about chiral center. How many chiral center in this compound? Suppose I am talking about X. This is carbon, this has a methyl. Perfect. We can put 1 hydrogen when you will balance, so 1 hydrogen, fine. Now left position, this position is CH2, am I right? This is CH2, so we can write CH2. And right position have, you can see CH. When you will balance, it has 1 hydrogen. So this is CH. So now you can see it has 4 different connectivity, methyl, hydrogen, CH2, and CH. It means X is your chiral. And simply you can check Y. If you look Y, this is Y. It has a methyl. It has a hydrogen. And this up branch is your CH. You can see this is CH. And this down is your CH2. So this is CH2. Again, it has a 4 different connectivity. So Y is also chiral. So this ring has 2 chiral center. It makes sense? Please tell me. Okay. How many chiral center in this compound? Tell me. How many chiral center? Very good. Everyone is saying 1. That is fine. Perfect. Can you tell me which position is chiral X and Y? Yes, Y is a chiral. Perfect. Absolutely perfect. So now you can see this is a very easy one for you to find the chirality. Now I am going to discuss another concept, that is CIPS rule. This rule is a priority order rule, priority of groups, priority order rule, and very important. So according to this, rule number 1 is high priority is given to high atomic number. Means, suppose this is carbon, it has fluorine, chlorine, bromine, and iodine. If you have a bit idea about periodic table, you can see this is halogen, which is present like this in periodic table. And you know that iodine has highest atomic number, than bromine, then chlorine, and then fluorine. So it should be atomic number trend is like this. So I told you that high priority is given to higher atomic number. So iodine will be first, bromine will be 2, chlorine will be 3, fluorine will be 4. Any doubt? Please tell me, any doubt about this? The rule number 1, any doubt? I don't think that it is hard. Okay. Now we are going to move rule number 2. So rule number 2 is, if you have same atomic number, and you know that in chemistry, if you have same atomic number, that is known as isotopes. So in case of same atomic number, priority is decided by mass number. Mass number. Suppose we have carbon, here we have fluorine, here we have chlorine, here you have hydrogen, and here you have deuterium. So as you can see, between fluorine, chlorine, hydrogen, and deuterium, chlorine has highest atomic number. First, whenever you have to assign priority, always follow rule 1. If rule 1 fails, then rule 2, like this. So rule 1 is fluorine 1, fluorine 2. Hydrogen and deuterium have same atomic number, but mass number is a different. Deuterium has high mass than hydrogen. So that will be your 3 and this will be 4. Any doubt? Please tell me. Perfect. So this is atomic number, priority according to atomic mass. Will they give mass? No. Listen. First of all, it is very, rare to ask this condition, the mass number condition. Generally, it is all about atomic number, means the isotope form will never give you. Suppose it will come, then you can say like which has higher atomic mass, and it will definitely be given in the passage which have high atomic mass. Okay. So don't worry about mass number. Now move to rule 3. Rule 3 is not a rule, it is common sense basically. Suppose we have a carbon, we have an H2, we have methyl, we have OH, and you have fluorine like this. This time we have not element, we have a group of atom, means a group, a molecule is connected to the carbon. So to decide the priority, you should focus the first connectivity. The first connectivity means the atom which is connected first to that group. Suppose in the top one, we are connected with carbon. In the right horizontal, we are connected with nitrogen. And in the left horizontal, we are connected with oxygen. And in the vertical down, we are connected with fluorine. So now you can decide the priority very easily according to atomic number. And you know that fluorine atomic number 9, oxygen, we can write down 9, oxygen 8, nitrogen 7, carbon 6. So the thing is very easy. Oxygen, fluorine 1, oxygen 2, nitrogen 3, carbon 4. Any doubt? Yes, I am saying whenever you have a group of atom, then you have to focus only the first connectivity. In the right, you can say the NH2 is nitrogen is bonded to the carbon. And here in top one, methyl's carbon is bonded to this. And here oxygen is bonded and here fluorine. So it is very easy to identify the priority according to atomic number. Which have fluorine has highest atomic number, then oxygen, then nitrogen, and then carbon. So that's why fluorine will behave as 1, oxygen will behave as 2, nitrogen 3, and methyl 4. What about this one? We have to decide the priority over here. Tell me which should be the highest priority. You can locate the position like horizontal right, horizontal left, vertical up, vertical down. Highest priority is, I think, bromine. Yes, thank you so much, guys. You are absolutely right. Bromine will be 1. Okay, after bromine, which one is second? Please tell me. Very good. Going good, going good. Nitrogen, perfect. So this is number 2. Okay, now the thing is, which is number 3 and 4? Yeah, someone is saying top carbon, top carbon, top carbon. Okay, you know why top carbon? Yes, the right, this carbon and this carbon is common. So if you get same thing, means carbon same, then try to connect with the next position, which is bonded to that. You can see here CO and CO is common. Next is here oxygen and next is here hydrogen. Definitely oxygen has higher atomic number than hydrogen. So this is your 3, this is your 4. Any doubt? Listen, don't worry about anti-clock and clock right now. I will discuss that thing in the R and S nomenclature. So don't apply anti-clock and clock here. Okay. Here we have to decide only priority. When I will discuss R and S form, then I will tell you. Why is top 3? You know why? Because this is C double bond OH and this is C double bond OH. So CO is common. Next element is oxygen, next is hydrogen. So oxygen have higher atomic number than hydrogen. That's why this is 3 and this is 4. Okay. Tell me about this one. Priority over here, this position. I can name this one as X, this one as Y. And this one supposed to be O and nitrogen. You can assign like this. Tell me. Okay, first tell me which should have high priority, means 1. Number one, please. Oh my God, you guys are so confused. Oxygen has higher atomic number than nitrogen. Oxygen is 8, nitrogen is 7. Yeah, oxygen will be 1. Nitrogen is 2. Perfect. What about 3 and 4? This is a bit complicated between 3 and 4. 3 is X, Y is 4. What is 3? X. Yes, 3 is X. Of course, X. The reason is that if you are balanced this carbon, you can see here we have 2 hydrogen. Perfect. And if you balance this one, here you have 3 hydrogen. So you can see here carbon with 2 hydrogen and carbon with 2 hydrogen is same. And next is carbon, next is hydrogen. So carbon has higher atomic number. So X will be 3, Y will be 4. Any doubt? Yes. Any doubt? Please tell me. Perfect, 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 perfect. We can discuss one more example with priority, then it will be very clear. Which have highest priority? We have a less than a minute, and join me again because this class is 45-minute Zoom session is limited. Please join me again, okay? After this means just this 1 minute, you can join me again. Yes. Fluorine is 1, okay. Nitrogen is 2, okay. And CH bromine is 3, okay. CHO is 4. Absolutely right. The reason is that you can see first connectivity nitrogen, here you have fluorine, here you have carbon, carbon. So nitrogen and fluorine, fluorine has higher atomic number 1, nitrogen 2. Now this CH2 is common. This is